Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are still on the topic plane geometry. In the previous video, we considered two properties of angles in a triangle. We saw that the interior angles of a triangle add up to 180 degrees. And an exterior angle of a triangle is equal to the sum of its interior opposite angles. In this video, we are going to consider types of triangles and their properties. So let's begin with the first type of triangle, the equilateral triangle. If you watch the video on mensuration, we did explain the equilateral triangle and its properties. In this video, we are going to consider the angle properties of an equilateral triangle. We know that this is an equilateral triangle because there is this line here, and this line here, showing that the length of this side and that side and that side are equal. So for equilateral triangles, all the sides are of equal length and all the interior angles are equal. So the interior angle of an equilateral triangle is 60 degrees because 60 degrees plus 60 degrees plus 60 degrees will give us 180 degrees. So if you take an equilateral triangle, all the sides are equal. And you will know that using the lines that have been used here. So we have this line here, this line here, and this line here, showing that all the sides are equal. Then the angles are also equal, as it can be seen here. The next type of triangle we are going to consider is what we call the isosceles triangle. For an isosceles triangle, two sides are of equal length. So when you, in this diagram, you can see that we have one line here and one line here, meaning that this side and this side are of equal length. But when you come to this side, the lines are two, showing that the length here is different from the one that you have here and the one that you have here. So for an equilateral triangle, you will see that there was only one line here, and another line here, showing that all the lengths are the same. When you consider the isosceles triangle, there is one line here and one line here, showing that this side and this side, the lengths are the same, but this side has a different length, so the line here is 2. Now, another property of an isosceles triangle is that two interior angles are equal. Now, what are these two interior angles? You will see that the sides that are the same, the angles formed at their bases are also the same. So this side is equal, the length of this side and the length of that side is equal. The angle that will be formed at the base of those sides are the same. So the angle formed here, if that angle is x, the angle formed at this side will also be x. So the two sides that are the same, the angle that are formed at their bases will also be the same. So the angle formed here will be x and the angle formed here is also x. I'm just using the x to represent the angle that will be there. So all you need to know about isosceles triangle is that two sides are of equal length, then two interior angles are also equal. The interior angles that are equal are the angles formed at the base of the two sides that are equal. Let's consider the next type of triangle called the scalene triangle. All the sides have different lengths, all the interior angles are different. So you can see that there is one line here. When you come here, there are two lines. When you come here, there are three lines, showing that the length of this side and the length of this side and the length of that side are all different. So for an isosceles triangle, there's one line here and one line here, showing that the length of this side and the length of that side are the same, but the length of this side is different, so two lines are used to show. When you come here, the length of this side and the length of that side and the length of that side are different, so we use one line here, we use two lines here, then three lines here. Also, all the interior angles are different, so the angle formed here will be different, the angle formed here will be different, and the angle formed here will also be different. When you have such a triangle, we see that you have a scalene triangle. Let's consider the last type of triangle that we'll be considering in this video, called the right-angled triangle. For a right-angled triangle, all the sides are different. Just like for scalene, all the sides are different. For right-angled triangle too, all the sides have different lengths. One unique thing about the right-angled triangle is that one interior angle is 90 degrees. So for right-angled triangles, one interior angle is 90 degrees. So just as you have here, I told you in a previous video that if you see this sign here, it means that a 90 degrees or a right angle. So this is forming a right angled triangle. All the sides are of different lengths, but one of the interior angles is 90 degrees. Whenever you have that, we say that you have a right angled triangle. Now let's use these properties that we've learned about triangles to solve some questions. Let's pick the first question. We are being told to find the value of the letter in the following diagrams, and we have been given our first diagram. So straight away, looking at this diagram, we can see that triangle THG is an isosceles triangle. The reason being that there's one line here and one line here, showing that the length of this side and the length of that side are the same. One thing that we've learned about isosceles triangles are that two sides are the same, then the angles formed at the basis of these two sides are also the same. So if this side is P, then we can say that angle TGH, that is angle TGH, this side will also be P. So you see, we've used the property to find the angle that is here. Because this is an isosceles triangle, two sides are the same. That is what the question is telling us. Using this bar here and this bar here, it's showing us that this side and this side are the same. Now when you have that, we say that the angles formed at their basis will also be the same. So if this side is P, then this side is also P. So now we have the interior angles of this triangle. We have here to be P, P, and 50 degrees. The question told us to find the letter here. The letter here is P, so we can find P. We know that the interior angles of a triangle sum up to 180 degrees. So if we add P to 50 degrees, we should get 180 degrees. P plus P will give us 2P. So we have 2P plus 50 degrees is equal to 180 degrees. 2P will be 180 degrees minus 50 degrees, which is 130 degrees. You divide both sides by 2, you are going to get P to be equal to 65 degrees. So you see, from this question, we've used the property of an isosceles triangle to find the value of P. Let's take another question. Now looking at this diagram, what can we see? We can see straight away that we are seeing this sign here, which means that this triangle ABC, is a right-angled triangle. We know that for right-angled triangles, the angle that you have this sign here is 90 degrees, which means that angle ABC is 90 degrees. So we have here to be 90 degrees, we have here to be 50 degrees, and we are supposed to find the letter here, which is Y. We know that the interior angles of a triangle sum up to 180 degrees, so we can say that Y plus this side here, which is 90 degrees plus 50 degrees, will give us 180 degrees. So Y plus 140 degrees will give us 180 degrees. So we can say that Y is equal to 180 degrees minus 140 degrees. So Y is 40 degrees. So if you have also used the property of a right-angled triangle to find the value of Y in this question. Let's consider our last question in this video. So we have triangle PQR. The interior angle here is 50 degrees, the interior angle here is 60 degrees, and you have been given here to be X. So you are supposed to find the value of X. So straight away from here, we have been given all the interior angles, so we can add them and equate it to 180 degrees, because we know that the interior angles of a triangle sum up to 180 degrees. So X plus 50 degrees plus 60 degrees will give us 180 degrees. This will give us S plus 110 degrees to be equal to 180 degrees. So X will be 180 degrees minus 110 degrees, which will be 70 degrees. So looking at this diagram or this triangle very carefully, you see that this angle is 50 degrees, here is 60 degrees, and x is 70 degrees. So all the interior angles are different. So this is an example of a scalene triangle because the interior angles are all different and the sides are also different. Thank you for watching this video. Pick more examples on triangles. In the next video, we are going to use the properties of angles in a triangle that we've learned in the previous video and this video to solve more questions. Bye bye.